Physicists claim that the universe began around 13.7 billion years ago, following an event known as the Big Bang. However, the real question is what triggered this explosion, and what was the reason behind it. Over time, researchers have delved into the science and history of our universe. The Big Bang has stood as the leading explanation for the phenomena we've observed. Many studies have been conducted with thousands of scientists contributing, and the data consistently supports the Big Bang theory as the primary model for the universe's formation. According to this theory, dark energy is a type of energy more abundant than the energy found in galaxies, and it's seen as the anti-gravitational force that drives the ongoing expansion of the universe since the Big Bang. Modern science has evolved significantly from earlier times, and with the progress of technology, new theories continue to emerge. Often, we find that things we once thought to be absolutely true are far from it. Physicist Michio Kaku has officially questioned the Big Bang theory. This skepticism arises because the James Webb Space Telescope has discovered 750 new galaxies that look radically different from what scientists had predicted. This discovery brings forth new perspectives, prompting a deeper investigation into how the James Webb Space Telescope is altering our understanding of the universe. Join us on this remarkable journey as we explore the farthest reaches of the observable universe and uncover more about these newly found galaxies. If you're keen on staying updated with the latest cosmic news, subscribe to our channel, give this video a like, share it to spread the word, and activate the notification bell. The images of the new galaxies taken by the James Webb Space Telescope are absolutely breathtaking. In a single frame, we can observe hundreds of galaxies, each more stunning than the last. These photographs are powerful and beautiful, leaving a lasting impression. However, what might surprise most people is actually the opposite of what you'd expect. For scientists, these images are astonishing, but they don't align with the anticipated results based on existing theories. In fact, more galaxies than expected are being observed, and these galaxies differ from the norm. They are smaller than anticipated, and their ages are quite remarkable. This unexpected finding has caused some concern among scientists, with even an article starting with the word panic to highlight the gravity of the situation. These newly discovered galaxies don't match what was predicted by established theories. For many years, the Big Bang theory has been the most widely accepted explanation for the origins of our vast universe. According to this model, the universe began its existence roughly 13.7 billion years ago after some mysterious cosmic event. However, these new images are challenging the previously accepted narrative about the birth of the cosmos. The photos captured by the James Webb Space Telescope challenge the current understanding of the universe's origins. Specifically, these images directly contradict the Big Bang hypothesis, which has long been viewed as an unquestionable truth by cosmologists. The galaxies shown in the images appear to be significantly smaller, smoother, older, and more numerous than what was predicted by the Big Bang theory. Notably, these galaxies are 2 to 3 times smaller than the ones observed by the Hubble Space Telescope, which defies the expectation of an expanding universe. According to the Big Bang model, as the universe expands, galaxies should appear larger as they move further away, yet the new Webb images show galaxies that challenge this assumption. Additionally, the smoothness of these galaxies contradicts predictions made by the Big Bang theory. This model suggests that galaxies should exhibit irregularities and structural variations due to their formation and evolution. However, the Webb images reveal unusually smooth galaxies, lacking the roughness and complexity one would typically expect to see in galaxies of this age. This observation appends the expected timeline for galaxy formation and evolution as proposed by the Big Bang theory. At the universe's inception, all matter, energy, and the building blocks of existence were packed into an incredibly dense point called a singularity. Within this singularity, the density was infinitely high, because of the extreme compression of matter and energy. The concept of the singularity is grounded in our current understanding of physics, especially Einstein's equations of general relativity. In this singularity, all matter and energy existed in an extraordinarily compressed state. The density of this point was so extreme that it held an immense amount of mass and energy within an incredibly small space, subjected to extreme pressure and density. Under these extreme conditions, temperatures would be unimaginable, exceeding any known temperatures. The energy contained in this dense, hot point is thought to have been the origin of the universe itself, marking the beginning of everything in our cosmos. Following the singularity, the universe began to expand, setting into motion the process of cosmic inflation, which took place over roughly 13.7 billion years, ultimately forming the universe as we know it. The universe initially expanded with incredible speed during the period of cosmic inflation, faster than the speed of light. It's as though the fabric of space itself stretched, pulling everything within it. This phase played a key role in shaping the large-scale structure of the universe. It smoothed out irregularities, created a more even distribution of matter and energy, and set the stage for the formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of expansion gradually slowed down. Even though rapid inflation occurred in the early stages, the universe expanded at a steady pace afterward, referred to as cosmic expansion. Scientists have observed the consequences of this expansion, including the redshift of light from distant galaxies. Redshift indicates that as the universe expands, the light waves from faraway galaxies stretch, shifting toward the red end of the spectrum. During the expansion, all the matter that makes up the universe was initially compressed into a tiny space. It was evident that matter couldn't remain in such a tightly packed area, so transformations began. As the universe cooled and expanded, particles like protons, neutrons, and electrons started interacting with the surrounding light and energy. These interactions were crucial in the formation of matter in the universe. During the first few minutes following the Big Bang, a process known as nucleosynthesis took place. Initially chaotic and irregular galaxies were expected due to frequent collisions. However, the galaxies captured by the James Webb Telescope tell a different story. Instead of seeing chaotic galaxies, the images reveal well-organized spiral and disk-like structures similar to those observed in our universe today. This unexpected finding questions the idea that mergers play a significant role in galaxy evolution. If these galaxies haven't undergone many mergers, it seems unlikely that small galaxies would grow to become hundreds of times larger, as was previously expected. This challenges the idea that galaxies grow through the merging process. Moreover, the optical illusion suggested by the expanding universe theory, where objects appear smaller because of the expansion, does not seem to apply in this case. As a result, what we thought we knew about the universe is now in question. Additionally, the age and quantity of the galaxies revealed by the James Webb Space Telescope further challenged the validity of the Big Bang theory. The James Webb Telescope is equipped with infrared filters that enable the study of distant galaxies by analyzing their color. By studying these colors, astronomers can estimate the age of the galaxies and their stars. If you enjoyed this video, please don't forget to hit the like button, share it to reach a wider audience, and subscribe to our channel so you can stay informed about our future content. The findings from the James Webb Telescope continue to generate a great deal of discussion and uncertainty in the scientific community. The unexpected discovery of these ancient, small, and smooth galaxies presents new challenges to our previous understanding of the universe's origins. As more data comes in, scientists are being forced to reconsider many of the foundational ideas that have shaped our understanding of cosmology for decades. These new observations have led to a reassessment of how galaxies formed and evolved in the early universe. The traditional Big Bang theory has long suggested that galaxies formed through a series of mergers, with smaller galaxies colliding to create larger structures over time. However, the images provided by the James Webb Telescope show galaxies that appear to have formed in ways that do not fit this narrative. The smoothness and size of the galaxies captured by the telescope contradict the idea that they should have undergone many mergers or collisions. In addition, the unexpected age of these galaxies further complicates the situation, forcing scientists to reevaluate the timeline of galaxy formation and the processes by which they evolved. Another critical factor in this reevaluation is the distribution of galaxies observed by the James Webb Telescope. The conventional theory of the expanding universe holds that as the universe grows, galaxies should become increasingly spread out. However, the James Webb images show an unusually high number of galaxies clustered together in some regions, which is at odds with expectations based on the Big Bang model. This observation raises important questions about the true nature of the universe's expansion and whether our current models are sufficiently comprehensive to explain all the observed phenomena. As the field of cosmology continues to evolve, the discovery of these unexpected galaxies may mark a turning point in our understanding of the universe. It suggests that we may be on the cusp of a new era in scientific exploration, where our current theories about the Big Bang and the origins of the universe are subjected to intense scrutiny and revision. This is a testament to the dynamic nature of science, where new evidence and observations often lead to paradigm shifts in how we perceive the cosmos. In the coming years, as more data is gathered from the James Webb Space Telescope and other cutting-edge instruments, our understanding of the universe's birth and evolution will continue to grow and evolve. It is possible that the answers we seek may challenge the very foundations of the Big Bang theory and force us to reconsider the entire framework of cosmology. While these discoveries raise more questions than answers, they also provide a glimpse into the incredible complexity and mystery of the universe that remains to be uncovered. For now, the scientific community remains divided on how to interpret the data, with some scientists holding firmly to the Big Bang theory, while others are exploring alternative models of cosmic origins. This debate is likely to continue for many years to come as new evidence and observations are integrated into our understanding of the cosmos. However, one thing is certain: the James Webb Telescope has opened up new avenues of inquiry that will undoubtedly reshape our view of the universe and its origins for generations to come. As we move further into the exploration of the universe's early stages, the revelations made by the James Webb Telescope have sparked a larger conversation about the validity of the Big Bang theory. Traditionally, this theory has been seen as the bedrock explanation for how the universe began, but the new findings are forcing scientists to ask difficult questions about the theory's accuracy. These observations suggest that we might be looking at a much more complex and varied cosmic history than previously thought. What is becoming increasingly clear is that the understanding of the universe's beginnings is far from settled. The images captured by the Webb telescope have illuminated new dimensions of the universe that were previously unknown to us. By pushing the boundaries of our observational tools, scientists are now discovering galaxies that appear to be far older, smaller, and more uniform than anticipated, challenging the notion that the universe followed a predictable and gradual process of evolution. If these galaxies were indeed formed in the early universe, their structural properties and age contradict the expected cosmic timeline established by the Big Bang theory. This has led to speculation that the universe may have undergone a different set of processes, one that could involve more complex interactions than the simple expansion suggested by traditional models. The idea that galaxies could form with such smoothness and size in the early stages of the universe suggests that perhaps other forces or processes were at work, ones that we haven't yet fully identified.